Okay, here's a quick review over the different story problems. A simple group, array, ordered pair, and multiplicative comparison. So we're going to use 5 times 3 in this example. So an array story problem is going to have something that is going to make kids draw 5 rows of 3 or 3 rows of 5, okay, or columns or whatever. So I might say something about on a cookie sheet, Sue places 3 rows of 5 cookies. And then the question would be, how many cookies are on the sheet? Okay, and then the way a kid would solve that is, because it says 3 rows of 5, they're literally going to draw 3 rows of probably 5 circles to look like cookies. Okay, and then the answer would be 15. And they might get the 15 by adding 5 plus 5 plus 5. They might do skip counting like 5, 10, 15. They might count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You know, it's hard to say, but they're going to get an answer of 15 cookies. So again, how they solve it is going to kind of depend on where they're at. All right, I got a little sun going in there, so I'm going to try to scooch over a little bit to get out of the sun. Okay. All right, so that's an array story problem. All right, multiplicative comparison is, there's multiplying involved, but it's also a comparison. So they're like, you have more than me, but it's not a comparison as far as in adding, where it's like, I have 3 cookies, my friend has 5 more than me. It's multiplicative comparison. So I have 5 cookies, my friend has 3 times as many cookies as me. So there's comparison, but it's not an adding comparison, it's a multiplicative comparison. So again, 5 times 3. So it's like, I have 3 cookies, or we could use apples, it's apple season. I have 3 apples, and my sister, I'll use Sue again because my sister's name is Sue. My sister Sue has, I have 3 apples, and my sister Sue has 5 times as many apples as me. Then the question would be, how many apples does Sue have? Maybe not the best grammar there. How many apples does Sue have, or something like that. Okay. All right, so I have 3 apples. My sister Sue has 5 times as many apples as me. How many apples does Sue have? So again, my picture here is going to be a strip diagram. So I'm going to have me, and I'm going to draw like a rectangle, and inside it, I'm going to put the number 3. Underneath it, I'm going to write Sue, and I'm going to do 3 rectangles kind of touching each other, like in a train, like carts next to each other. So 3 rectangles drawn horizontally next to each other, and again, about the same size as what mine is, because they're representing the same unit. And then I'm going to, she has 5 times, oh, so I need 5 of them, sorry. So mine is worth 3, she's 5 times as many. So she's going to have 5 rectangles the same size as mine. Each rectangle is worth 3, so that she would have 15 apples. That would be multiplicative comparison. An ordered pair is going to be like when you use a tree diagram. So this would be like, I have 3, oops, I don't know why I wrote that. I have 3 types of bread. Okay, so maybe I have wheat, white, and maybe a flatbread of some type. Okay, and 5 types of, I don't know, topping. Or let's do probably meat, sounds better. I don't know if I can think of 5 types of meat. Okay, and then maybe those are roast beef, ham, turkey. I don't know, I'm running out of meat. What other kind of meats are there? Maybe bologna, and we'll do tuna. I don't know. That's a fish. I don't know if technically that counts as a meat or not. And I gotta keep scooching over here because of that darn sun. Right? It's nice to have the sun. It just messes up my video. All right, so let me move my camera over. Okay, so I have 3 types of bread, wheat, white, and flat, and then I have 5 types of meat, Okay, so roast beef, ham, turkey, bologna, and tuna. Okay, so the question would be, like, how many, I don't know, 1 meat sandwiches can I make? Okay, all right, and so then for this one, you're going to make a tree diagram. So you have your, what are my 3 breads? I have wheat, white, and then my flatbread. And then from each one of those, you're going to do 5 little branches for each one. Probably should have spread mine out more. And then we have our sandwich meat. So like roast beef, T for turkey, ham, bologna, and tuna. And then roast beef, what was that? Roast beef, turkey. Oh, I see. Turkey. Okay, ham, bologna, and tuna. Roast beef, turkey, ham, bologna, and tuna. And on the flatbread, off those 5 branches, I'm going to write roast beef, turkey, ham, bologna, and tuna. Okay? And so here a kid's going to, again, they might do 5 plus 5 plus 5, or they might do 5, you know, if they know 5 times 3 is 15. But this is usually early childhood, so they probably don't know yet just their multiplication facts, but they might be getting there. But again, there's 15 combinations. The way you read this off is wheat, roast beef, wheat, turkey, wheat, ham, wheat, bologna, wheat, tuna. And that's how you read off of a tree diagram. So there's 15 different combinations there. That's where we get our answer. Okay, simple groups for like 5 times 3 is where there's not going to be any mention of the aforementioned things. So no combinations of how many sandwiches, no rows to make you draw an array. There's not going to be like, I have 5 times as much as you or 3 times as much as whatever. It's not going to have that language. It's going to be simple groups. So it's just going to be 5 groups of 3. So it could be something like, I have 5 friends. Okay, I give each friend 3 pieces of candy. And then the question was like, how much candy did I give away? Or something along those lines. So there's nothing about rows, nothing about columns. There's no combinations. There's no, you know, like I have 5 times more than you do. It's just I have 5 friends and I give them 3 things each. Now, kids are probably going to just draw 5 circles. Okay, sometimes they'll draw little faces by each one, you know, like these are their friends. Or they might draw a stick person, or, you know, sometimes kids get creative there. And then 3 pieces of candy. So inside each circle, they're going to put, you know, like maybe 3 little rectangles for maybe the candy bars or pieces of candy. They might draw circles. That doesn't matter. They might draw stars. It really doesn't matter. Okay. All right. So then again, how a kid might do this is they might go 3 plus 3 plus 3 plus 3 plus 3. You know, they might count. Hard to know, but they're going to get an answer of 15 pieces of candy. Okay. That's just simple groups. All right, now, as far as strategies when we get to bigger numbers, okay, say I give you, say we do like 23 times 47. Okay, the traditional algorithm would be 7 times 3 is 21, so you put a 1 with a little 2. 7 times 2 is 14, 15, 16. And I'm going to cross that off. You put a 0 as a place value holder. Some teachers do an X. I've seen that before too, like using just an X to move over to the next place. 4 times 3 is 12. You put a 2 below with a little 1. 4 times 2 is 8. Add 1, you get 9. And then you add down. So 1 with nothing is 1. 6 and 2 is 8. 9 and 1 is 10. So you get 1,081. That's your traditional algorithm. Now, partial products then focuses on place value. So you draw 23 times 47 and draw kind of a little line underneath with a little off the right end, kind of a line going to the right. So it's more like an upside down L. And you focus on the 7 and you notice that that's really 7 times 3 and really 7 times 20. It's not 7 times 2. It's really a 20 up there. And then when you move over to the 4, you realize that's really a 40 times 3 and a 40 times 20. So again, partial products focuses on place value. So then a kid would multiply. So 7 times 3 is 21. They're going to line that up. 7 times 20 is 140. 140, line it up. 40 times 3 is 120, line it up. And 40 times 20 is 800. And they're lining these all up vertically underneath. And then they're going to add. So they get 1. And they get what? 4, 5, 6, 7, 8. And then they get their 10. And they get 1,081. Okay, so, and again, they might do this in steps, or they might, since they didn't have to regroup here till the end, right? Here they got a 10 and they can regroup. But otherwise, you know, they might just do it all at once, depending on how complicated it is. All right, let's do the box next, because the box or foil kind of goes with partial products. So in the box, it's an area model. So I'm going to break my box into 20 and 3 and 40 and 7. So I'm breaking it by my place value. So again, definitely partial. And I'm going to multiply each to get the area of each one. So I have a rectangle cut into 4, and I have 23 on the top and 47 on the bottom, or on the right side. It doesn't matter which I did where. 20 times 40 is 800, so I'm going to put that inside that rectangle. 3 times 40 is 120. I'm going to put in that rectangle. 7 times 20 is 140. I'm going to put it that rectangle. 7 times 3 is 21. I'm going to put it in that rectangle. And notice you get the same numbers you got when you did partial products. It's just a visual, we call this a graphic organizer, just helps you get organized. So then here a kid might add like 160, so then they get maybe 800 plus 160, get 960, then add the 20, oh, what did I lose here? Sorry, how about 260? That would be better. Okay, so they might add the 140 and the 120 and get 260, add it to the 800 and get 1,060, then maybe add the 21 in and get 1,081. Or they might just line it up like they did up there to get the answer. All right, let's look at lattice. So lattice, you're going to make a rectangle or square cut into 4 pieces with a plus sign in the middle. And you don't put 20 and 3, you put 2, 3, 4, 7. And then you draw diagonals going from the top right corner to the left of every square and do like dashed lines. So you do dashed lines going down from the right corner to the far left corner of each box. Okay. All right. And then you write a 2-digit number in each little square. So each square is going to have a 2-digit. Now, if you get a 5, you have to write 0, 5. So 3 times 4 in the upper right corner is 12. So 1 above the dash, 2 after. 4 times 2 is 8, so you write 0, 8 in the box that's in the far left. 3 times 7 is 21, so 2, 1, 2 above the dash, 1 below in the bottom right corner. And the bottom left, 2 times 7 is 14, 1 above, 4 below. And then you add down the diagonal. So on the far right corner, you have a 1, so you write a 1. 4 plus 2 is 8, so you write an 8. And 8 plus 1 is a 10. Now you put a 0 and you do regroup to the next area. 0 plus 1 is 1. And so your answer is right there. 1081, 1081. All right, now the last one is a grid. And I have too big of a number to do on a grid, so we're going to do something smaller. So say I do 12 times 12. What you're going to do on your grid is count out 12. So 1, 2, 3, 4, 5, and I'm going to pause for a second. I'm going to do 12 this way, 12 this way, and I'm going to mark off my 10s and my 1s. So I'm going to pause and go do that quick. Okay, so on my graph paper, I made a 12 by 12 square, and I marked off 10 and 2 and 10 and 2. Now, what I'm going to do is draw those lines vertically and horizontally. So this is like a to scale box drawing. Do you see it? I have a 10 by 10, I have a 2 by 10, a 2 by 10, and a 2 by 2 in the corner. This is like base 10 blocks. You just add it up. So I have a flat here, so I have 1 flat. And then do you see how I have 2 longs going this way and 2 longs going that way? So I have 4 longs. So here's 2 longs up here, 2 longs over here, and then in the corner I have 4 singles. Now sometimes you have to regroup. This time we didn't have to. All right, so I have 4 singles, so my answer is, and again this is 12 times 12, so it's a different problem, but I have 1, 4, 4, because I have 1 flat, 4 longs, and 4 singles, or 144. And so it's a to scale box drawing is what it really is on the grid. But if you had more singles than this, you might regroup and make them more longs. If you have more than 10 longs, you might circle them and make a flat out of them. But literally kids can get the answer without really multiplying at all.